Alright, from beginning. Alright, so we're gonna do solving. Okay, gotta get the pen up. There's two types, linear and nonlinear. Well, that ain't right. Linear inequalities, nonlinear inequalities. A linear inequality can be written if it's and here we're in one variable. Actually, we'll do two variables. I'll start with two variables. So a linear inequality can be written like this. And actually, that doesn't need to be an equal sign. And if it is, it's not really an equality, it's an equation. So just put a box there. In this box, you can have greater than, less than equal to, greater than equal to. Okay, so that can be any of those. Nonlinear is basically going to be everything else. So if it can't be written in this form, basically it's nonlinear. And nonlinear methods will allow you can use nonlinear methods to solve linear problems, but you can't use linear methods to solve nonlinear problems. Okay, so and actually, if you have something linear, the very specific way to solve it is is very simple versus the more generic way to solve a nonlinear problem. So that's in general for a nonlinear, you basically have y is something f of x. Okay, so y is equal, again, y can be written as y greater than, less than, greater than, equal to, or it could be even more generally, you might have y as a function of something else. You might have y squared equals f of x, or y so and so, or but let's see here, or it may be just completely mixed up. But basically, a nonlinear is basically everything else. It may not even be in this form. It may be difficult to write in that form, but it can be done. Um, so basically, you start with linear. So I said in general, if you have it in two variables. So let's go down. Originally we had two variables. So originally we had two variables on the previous slide, but now let's do so now we're going to do one variable. More specifically, let's just say if y is 0, then we have basically we can write this as something 0 equals mx plus b, basically for a linear, and any of them can be written like that basically. So let's go ahead and try to solve something in this form. So let's just say we have basically from now on we're going to assume y is 0 and just do this in one variable. goodness, not what I wanted to do. I wanted a highlighter. So basically from now on, we're just going to work in one variable. We're not going to worry about two things. We'll just have an x in our equations from now on, which is what is of more interest for us for what we're doing right now in class. So all right, so let's try some examples of linear inequalities. Alright, so let's just say we want to solve, and that is not going to be very visible. If I want to solve that, well, I can, I'll make that a negative. Alright, so negative 3x plus 5 is greater than 2. So, same as when I solve an equation, a linear equation, just isolate x. So, you got 5 is added and divided by negative 3, so I'm going to do the opposite. I'm going to subtract 5, and I get minus 3x. And I'm not even going to worry about what that symbol is. It's something, and that's going to be a minus 3. And if I divide by negative 3, now I'm dividing by a negative, so this sign should reverse because I'm dividing by a negative. So now I'll basically end up with x is less than 1. Okay. So that's my solution. That's what this simplifies to. Okay. And that's all there is to that. And if I wanted to graph that, I basically have 1 right here, and x's, my solutions are less than 1, so the x's are going to be here on down. Okay. And this is 1. Okay. So now that's kind of I think everybody's okay with solving linear equations of that form. So that's why and for nonlinear equations, I'll just well, let me work one more linear. So do one more linear. Say I want to do 5x plus 3 not equals. Less than equal to 2x minus 1. Okay. And wait a minute, I got a dog going nuts in here. I gotta pause this video. Yeah. Back to the desktop. Back to the desktop. Escape button is not working. I love Windows. Escape. Okay. Pause this thing. Okay. Back to this. Slideshow from beginning. Alright. So along the same lines, doesn't really matter which side I go with. I'll just subtract 3 and subtract 3. I have 5x is less than equal to 2x minus 4. And this sign is not going to change because I subtracted. It only changes when you divide by a negative. Okay, so there's no issue with the sign yet. So now I can subtract 2x, and erase this little stray mark. Now I have 3x is less than or equal to minus 4. Okay, so let me double check. That's 3, that's 0, that's 4, -4. Alright, so divide by 3, divide by 3. And of course, this sign, yeah, I'm dividing by a positive, so this sign is not going to change. So basically, now I basically just have so I basically just have, oh, that ain't gonna cut it. So what I have is x is less than or equal to -4/3. And again, just like before, hopefully I got that in the right direction. Yeah, I guess both of them ended up being less than. Wasn't trying to do that, but whatever. All right, so pick another color that will stand out. So do my graph, the x direction. So if I was going to graph this, if this was -4/3, then it's basically going to include it and be everything that's less than the value itself. Okay, so that's how you'd graph this thing. All right. And that's terrible. That's pretty bad. Go on to another slide. Darn it, it's not what I told you to do. Alright, so x is less than 4/3. I'll go do that over here. So if this is -4/3, then less than or equal to, it's going to be here on out. Alright, so that's all there is to that. And the solution is, so that's all there is to this. Okay. And of course, again, with these, you can write the solution in one of two ways. You can write the solution as, to be technical about it, I guess. I didn't really say it and stress in the first one, but I guess technically I should write this as all x's such that x is less than or equal to -4/3, or equivalently, I can write this as going from -infinity and stopping at -4/3. And including it. So basically, yeah, so basically either of these would be acceptable. Okay. So that's how you deal with the linear inequality. So now let's get to the trickier thing of solving nonlinear inequalities. So I'll go here. Next slide. So what if I want to solve, think of something factorable. Let's just try, well, I guess it doesn't have to be, but I prefer it. Let's just try it. If I have 2, let's just see, I have like 2, and make that positive, factors 2, so I'm going to do 3x and x squared plus, okay, so x squared plus 3x plus 2, that'll work. Rewrite this. Trying to think of a problem off the top of my head. I gotta make sure it's gonna work right ahead of time without getting too complicated. So I got x squared plus 3x plus 2. Let me double check this. This is actually recording before I proceed. Hate to waste a bunch of time. Yep, we're recording. Okay. Had that happen. I've talked for an hour and the thing wasn't recorded and had to do it all over again. So a little bit paranoid. Alright, from current slide. Alright. So x squared plus 3x plus 2. And that is, let's just say that is less than or equal to 0. Okay. So, and actually let me modify this problem just a bit. I guess I can't really. Alright, so the first thing is I already got it equal. I'm going to go ahead and drop this inequality symbol and pretend that it's so drop inequality. So that's the first thing you need to do. Okay, keep doing that. So you're going to drop the inequality first. Okay, so I'm going to drop this and treat it as an equal sign, basically. Black will show up. So now, what I have is x squared plus 3x plus 2 equals 0. Okay. So now, we know how to solve this. All we have to do is factor. We could complete the square also, but for this one we can factor it. So we have x and an x, and two factors of 2 that add up to 3 are going to be plus 1 and plus 1, or plus 2. Right. So basically, I got two things being multiplied to give me 0. If I have a times b equals 0, that means that one or two things has to be true. A equals 0 or b equals 0. In this case, again, we have two things. This, I keep doing that. Hit the highlighter. We have this is one thing being multiplied, and this is the other thing being multiplied. So we have two things. Okay, we have our A and our B, one in yellow and one in orange, being multiplied to give us 0. So basically that means that either this has to be either this has to be 0 or this has to be 0. Okay, those are the only possibilities for you to get 0 here. All right. So we basically have x that is not visible. We actually have x plus 1 equals 0 or x plus 2 equals 0. Okay, so so what we're actually solving for, you notice we dropped the inequality here. Okay, this top part we got rid of, so basically we're just figuring out when it's equal to 0. So now what we're solving for is what actually makes this thing here 0. Okay, so then when we get that solution, we'll figure out what happens when it's not 0 by using test points. So basically, now let's just solve these two things. So x plus 1 equals 0 and x plus 2 equals 0. So we have x plus 1 equals 0 and x plus 2 equals 0. So to this, so x equals minus 1 and oops. X equals minus 2. Right, so that tells me that I have this number line in x. I have this is negative 1, and that's when I get 0. And this is 2, and that's when I get 0. Okay. So the function is 0 at -1 and 2. So these are zeros. So I want to see what happens in these different regions. I want to see what happens here, here, and here. Okay, and that'll take care of the entire number line. Because right now, I only know results for two values, here and here. So I only know the answer for two numbers. I need to figure out the rest of the numbers. There's an infinite number of values here, infinite number of values here, infinite number of values here. In each region, the behavior is going to be uniform. So if I get a positive here, everywhere in this region is positive. If I get a negative here, everywhere in this region it's negative. If I get a positive here, everywhere here it's positive. So basically, you're just going to have consistency in your regions. Okay. Because in order to cross from, you can't really have it to say that something is positive in one spot over here and negative in one spot over here would be to say that you move from positive to negative, which means you crossed a 0. But we just said you can only cross zeros here. So that's why you can't go. That's why everything has to have the same sign in each one of these sections, because we've already said our zero, the only time you can cross 0 is when you move from the left side of -1 to the right of -1. That's the only time you can cross a 0 to go from negative to positive, or vice versa. All right, so now let's see here. What do we do? So I'm going to pick some values. So let's just say right here, I'll just pick something easy. I'll just do -10 since it's a round number. Easy number here is 0 and +10 here. Okay, and I'll change that color because that's a little hard to see. -10, 0, and 10. All right. So basically, now let's just check the original equation. So our original equation was x plus 3x plus 2 is less than or equal to 0, I believe. Yeah, so x squared plus 3x plus 2 less than or equal to 0. Now check. So now I'm going to test. So let's try x equals -10. Okay, so for -10, I get let's see here, -10 squared plus 3 times -10 plus 2. I want to check question mark that holds. So let's see here, 100 minus 30 plus 2 is calculator out already. All right, so let's see here. Of course, I know that's going to be positive, so clearly it's false. But let's see, 100 minus 30 plus 2, 72. So this is a question. So basically, the question is 72 less than or equal to 0? And the resounding answer to that is false. So this part fails. It's not in our solution set. So let's check 0, which should be easy to do. So let's check x equals 0. Okay, I guess I'll switch back to black. Okay, so let's check when x equals 0. I have 0 squared plus 3 times 0 plus 2 question mark less than or equal to. Yeah, okay. 0. So we basically have this 0, 0, so 2. Wait a minute. less than equal to 0. Huh. Can I choose something that has no solution? Oh, I think I chose something that has no solution. No, I couldn't have. What's going on here? Okay, now wait a minute. X plus 3, it's going to be 2 factors. Add up. Let's do this. 2 and 1. 2 and 1. Oh, gracious. Yeah, that should have been a negative 2. Knew something was wrong here. That should be a negative 2. So this should be, this number line is off. Great. Darn it. Yeah, y'all probably been watching this for a few minutes wondering what the heck I'm doing. So let me change this. Okay. 10, so this should be negative 2, and that's negative 1. So again, I'll pick negative 10. I'll pick 0 over here, and I will pick between here and here, I guess I'll pick negative 2 or negative 1.5, I guess will work. It's between those two values. All right. So what I've done so far will still apply, and just a simple mistake. All right. So it doesn't really make a big difference. So we still so now we've still tested this part, and it's invalid. So that's still not going to be valid. What we're on right now is this part now instead. So we've tested 0, and 0 failed. Okay. So basically 2 less than or equal to 0. That is false. Okay, so that's false. So again, now this region is going to fail. So now let's check this middle part. So let's check when x equals 1.5 or negative 1.5. So alright, so x equals negative 1.5. Then we have negative 1.5 squared plus 3 times negative 1.5 plus 2. Check that that's negative. Alright, so basically I have I'm going to plug this whole thing into my calculator at once, and negative 1.5 squared plus 3 times negative 1.5 plus 2. That's going to be negative 0.25 less than or equal to 0, question mark, and that is true. So basically, we know that this part is going to check out. So basically, this section, and since it's equal to is greater than or equal to, less than or equal to 0, this is where it's equal to 0, and this is where it's less than 0. So this is your solution set here. So I'll redraw this from negative 2 to negative 1. Okay. Alright, so we basically have x, and our solution was from negative 2 to negative 1. This middle region right here, middle line section. Alright, so that was our solution set. So now basically we know that our solution is all x's. Solution is all x's such that x is between negative 2 and negative 1. Or I can just look straight at the graph and say x Well, I won't write it like that, I suppose. Well, I can. X is in the set from -2 to -1. Okay. So either of these is acceptable as an answer. Okay, so this is set notation. And this is interval notation. Okay. And I'll do one more of those. I'll just change the sign of this. Let's see here. Actually, I'll do let's see. Pick something else. It's another one I can do. Solve. We'll say I'll do x squared plus 5x is greater than or equal to 7, maybe. Let's see here. Let me double check that that'll work before I start. Let me see. X squared plus 5x minus 7. Factor that. Okay, that's not factorable. Two factors of what? Really? Wait, two factors of -7 is going to be 2. Oh, no. 10 is what I wanted to do. 2 and 3. 2 factors of 7. Oh, yeah, 7's prime. What am I thinking? That's not going to work. 7 is a prime number. Thinking of something else. What value would work? 8. I want to do 10, but let me see. I guess I can do 3 and 2. Factors of 6, I guess. Guess I'll do negative. I guess I'll do negative and do 6. 6 will work. Okay. Alright. So I'll just do 6. Alright. So the first thing here, again, drop the inequality. We have x squared plus 5x equals 6. Okay. So when you're solving a quadratic, you want, or basically anything except for a line, you want to get everything on one side. So subtract 6, and I have x squared plus 5x minus 6 equals 0. Okay, so now I can factor this thing into x equals 0. So two factors of -6 that add to 5 are going to be -1 and +6. So now that means that x equals 1 or x equals -6 basically. So x minus 1 equals 0, and x plus 6 equals 0, which means that so x equals 1 or x equals -6. So I'm going to go to the next slide and do a number line from 1 to 6. Excuse me, from -6 to 1. And I'll choose over here -10. Over here I'll choose 0. And over here I'll choose 10. Just to make it easy on myself. Round numbers. Alright. And you can choose anything you want to. It doesn't really matter. Let's see. So we got x squared plus 5x minus 6. So x squared plus 5x minus... Oh, I'm writing this on the wrong slide. Eraser. go to the right slide. So I had x squared. I'll go here. X squared plus 5x minus 6 is, or actually is greater than 6 is what we started with. Is greater than or equal to 6, I believe is what I had. Yeah. So I want to check this now. Check to see if this actually holds. Okay. So I'm going to try it for a negative 10, which is my first region right here. So if I do it for negative 10, so when x equals negative 10, and I guess I can do it on this slide for x equals negative 10. I have x squared 5x 6. I have negative 10 squared plus 5 times negative 10 question mark greater than or equal to 6. So we have 100 minus 50 is greater than or equal to 6. So that is most certainly true. So this part's going to be your solution. So let's check for 0. So when x equals 0, I have x squared. So I have 0 squared plus 5 times 0 greater than or equal to 6 question. So that's basically 0 and 0, so that's false because 0's certainly not greater than 6, so that's false. Okay. So this side is going to fail. For positive 10, and usually for positive 10 we have x equals 10, and we have 10 squared plus 5 times 10, and we can already see this is going to be true. Huge positive, greater than 6. Basically this amounts to 150 greater than or equal to 6, which of course is true. So this region is going to be in my solution set. So basically it's greater than or equal to, so I'm going to include the boundary. Okay, I'm going to include this part, going all the way to negative infinity, and I'm going to include this part going all the way to positive infinity. So basically my solution is a union of two sets. The set from negative infinity to 6, negative 6, and from 1 to infinity. So basically my solution is going to be, based on this graph, it's going to be minus 6. Let me see, x goes from minus infinity to negative 6. So it's going to be minus infinity to negative 6. And it's also going to be from 1 to infinity. And actually, it's going to include this boundary because these are included. Great, just erased by accident. Yeah, it's going to include the boundary, so it's actually going to be a bracket on the other side. So it's going to be a bracket here, and again, be careful. The union, these sets do not overlap. If you say it's the intersection, you basically get an empty set. So I'm taking two separate pieces and they form a set. So I'm going to take the union of those two sets. And that is going to be the final answer to this problem. Okay. So hopefully this helps y'all in solving some of your nonlinear and your linear inequalities. Okay. And that should be the end of this one. Alright, so escape, keep, and stop recording.